That is so loud. Okay, thanks for coming along, everyone. Welcome to we number 6 now, I think. Simulation Summer School 6th edition. Thanks very much for coming along. Today we've got a virtual office hour with Mark Lai from University of Southern California. He's an associate professor. Mark is and two grad students, are they?
Yeah, those are Winnie and Ichi.
Winnie and Ichi, yeah. Have prepared an absolutely fantastic series of videos. So this is an asynchronous session. There's videos up on YouTube. They're connected to the summer school, but they are in a separate playlist. And they basically introduce Monte Carlo simulation studies, starting from like extreme basics, like with R-norm, which we've seen already. And by the end of the series, you're doing simulations of structural equation modeling. So I'd really recommend watching all of them if you've not got that far so far. Obviously, it being asynchronous, we're not expecting everyone to have seen them already. And the purpose of this session is to just ask Mark some questions about Monte Carlo studies, anything you might have struggled with in some of the videos so far, and maybe if you want any expansion on anything, this is the perfect place to do it. So, does anyone want to start us off with a question? You can either use chat or you can use microphones if you like. I think you are able to unmute or put your hand up or whatever. And as we're recording, I will read out the questions just so if you do put them in chat.
Yeah, and I just wanted to say before we head to the questions, so I put the materials in on GitHub. I put the videos on the playlist. I mean, something I tried in the during the pandemic when I was teaching. I kind of tried to make videos. So I don't know how it works out for everyone, but feel free if it's something you're not used to or you couldn't find the materials. Just I'm happy to go over something again in real time. Yeah.
Great, thanks. I've put the GitHub link up on the chat. And in the videos, it also gives you an introduction on how to use GitHub as well. So that's just everything you need in one package. So it's brilliant. So that's where all the materials are. So maybe I'll get started off with a question. I noticed that it's more about the Monte Carlo papers, like the papers that are sort of surrounding Monte Carlo simulations. I just wondered if you could tell us a little bit about maybe the peer review process that goes through those goes on in simulation studies. What sort of comments do you get? What sort of is it like as like complicated or potentially hornlocky as like not sort of traditional studies?
Yeah, that's a wonderful question. So I can tell you what the process is for me. So we usually put papers in what we call methodological journals. So places like psychological methods, structural equation modeling. I mean the British Journal of Mathematical and Statistics Psychology, of course, and places like multivariate behavioral research. I mean, sometimes it's more even kind of in statistics journal, for example. The process, I think, is pretty similar to a traditional submission. It's just we usually don't have data or real data, even though sometimes we have secondary analysis to just demonstrate a method if we are doing method development. In terms of the review process, for me, so the reviewers are kind of focusing on it could focus on the design, it could focus on whether your contribution is good enough to whether the findings is actually something that would make sense based on just standard statistical theory, or it's just incremental increase in knowledge, or is it a good contribution to our knowledge of a method. But one thing I kind of find is maybe a little bit different is because you are doing simulation. So with simulation, you can always it's computational cost, but you are not going to recruit more people. You don't need that extra time and effort. So sometimes reviewers would just ask you to add more and more in terms of so I kind of use it to compare it with an ANOVA design, but kind of the difference is you have hundreds or thousands of conditions sometimes. So it's kind of one standard thing they can ask you is to look at the process or look at the results. If you change your data to look like this or change your population to look like a certain other characteristics, what would be like. So it's sometimes time consuming, maybe not as time consuming as going out and recruit more people, but still is a lot of computational cost. But so that's kind of the process. That's kind of the reviews that I usually got when I submit papers. They ask you to run more, but sometimes they want you to show it can demonstrate practical values. It can be applied in real data. If you say two methods, one method is better than the other, would you be able to find that difference in a large-scale public data set or whatever data set you can find, and that's kind of the thing we always want to, as a methodologist, we still want to be it's applied in nature, so our findings to be related, to be helpful to people who are actually using those methods. Yeah.
Great.
So it goes through, sometimes it can take a long time, sometimes it can take a short time. So but I guess the difference is really, to me, is they can ask you to do many more simulations to kind of get through. Yeah.
Okay, great. And so anyone else, if you want to chime in, I have got some additional questions, but obviously yours are more important. So if you've got anything, just put your hand up and we can interrupt. Anyone else? Oh yeah, great, Helena, please. Can I ask you to unmute? There we are.
I saw Jeff raise the hand. I don't know what it is.
Oh yeah, we've got Jeff and we've got Helena. Yep. So
okay. I might have pressed something by mistake. I don't have a question. I really apologize.
Oh, don't worry, it's fine. Thanks. Sorry about that. Okay, Jeff.
Sure. So I do a lot of kind of resampling based methods, so bootstrapping and Bayesian Monte Carlo simulations. And so I was just wondering if you want to compare, let's say, a non-resampled approach to a resampled approach, does that just increase the order of complexity of the Monte Carlo, or are there shortcuts to kind of make that a little bit more efficient?
So I just wanted to make sure I understand the question. So if you have resampling and bootstrap, and your question is if you use a standard model-based approach compared to a bootstrap approach in your analysis, does that include increase the complexity of the analysis?
I guess what I'm saying is that if, let's say I want to use Monte Carlo simulation to compare something that is itself already a simulation, do you just sort of do a lot more iterations, or what do you do with that?
Yeah, that's a great question. Actually, my dissertation was on a simulation study comparing bootstrap method that I developed for multi-level model and standard multi-level analysis. It took me, there's a lot going on with that paper, but it took me 4 years to publish that paper because the computational time is a lot. Because you're imagining if I have 1,000, I forgot how many I have, but let's say I had 1,000 replications in it, but in each replication, each simulated data set, I do a bootstrap which draw 1,000 samples. So we are talking about 1,000 to the squared number of analyses for each replication and then multiply it by 100 conditions that I have to use like a supercomputer. I mean, I connect to a server it still took me like a few months to run all the analyses. So it's more complex. I think in terms of efficiency, there are ways to increase that. If you're doing Bayesian, maybe using like a better starting value, or if there are ways to like to save the computational cost in any way that would like, because everything would multiply up. So that's something to explore. With Bayesian, I think like if you're doing STAN, you probably want to pre-compile your model, so that you don't need to like packages like BRMS, they usually pre-compile every time you run it, but you want to like ask it not to pre-compile so that it would run faster. If you're doing bootstrapping, then you might want to decide like how many bootstrap is enough, because there's like a trade-off. We know we want like 1,000 bootstrap samples usually, but if like with a simulation that's kind of not practical, then you might kind of reduce it to 500 or something. So it's there are some trade-offs that need to be made. That's what my take for your question. But that's a great question.
Cool, thank you.
Mm-hmm.
Great. Do we have any other questions? Not at the moment. Okay, great. So how might you handle like researchers' degrees of freedom in Monte Carlo studies? Because this feels like it is all researchers' degrees of freedom. It's not like in experimental where you're limited a little bit. What's the plan? How do you go about planning them to make sure that you're not fooling yourself, if you like?
Yeah, that's a great question. It actually is something I've been thinking about. And I mean, there have been people trying to push for that, like more transparency in simulation studies. And if we kind of compare to compare like the simulation tradition with say like the open science movement in psychology, is actually like we are supposed to be the people who are advancing the methods, but somehow we are not like doing that for ourselves, because there's I mean, in the past at least, people like don't share their codes for like how they simulate the data, which I think it's getting more improvement. Like reviewers might ask you to share your code. I generally share my code, like at least for the past couple of papers, I would share my code for like how I simulate the data. And that's just kind of hopefully one progress that can be seen. But it's there could be a lot of researchers' degrees of freedom in the process. You can talk about like what conditions you choose. Are you just choosing particular conditions to make the results that like to be in favor of your particular method? And personally, I think it's like not necessarily bad if your intention is to illustrate, because like with real data, with methods, you're not necessarily like trying to generalize to say your method would work for every situation. Maybe your point is to make the case that your method would work for a particular type of data, even though that type of data might be rare, but there are situations you might want to use that. But I guess it's making clear like that's your point. It's not like trying to overgeneralize your findings of the results. And I think there are efforts trying to be pushed, but it's not yet like the result hasn't been realized. But I know like there have been papers shared, preprints about like why we should be replicating simulation studies, which hasn't been done a lot in the past, unfortunately. And I think there's actually an effort led by somebody in Germany in the Replicability, which would an effort to try to replicate simulations.
Is that the many simulations study? It's a bit like a mini labs, but many
I don't know. I heard about that a while ago. It's by let me try. Okay, I saw. I'm going to put a link on that on the chat.
Okay.
So the people are like ANOVA, Roth. I mean, yeah. So I think it's a great way to kind of learn doing a simulation study by like actually replicating something that had been done in the past. Yeah, and I actually like while I'm preparing the workshop, I was like I kind of had some time. I kind of actually started like replicating one of the studies. I think it's no longer there. They have a list if you click on like replications in progress. Well, actually, they have in the page they have maybe I can just share the screen if that's.
Oh yeah, that'd be excellent.
Yeah. So I mean, it's not something I created, so I'm not taking any credit here, but I'm just pointing out there's like a resource here that they kind of encourage people to pick a paper and try to replicate a study. And I think the team, they were like trying to make a paper out by like replicating simulation studies. And the important thing here is because a lot of the times when people decide what method to use, what parameters to set, it's a lot of times it's based on previous simulations, like the guidelines. But if the simulation are not correct, then like it kind of, the whole foundation is kind of on a shaky ground. And that's a huge problem for psychology and other like related disciplines that rely on like simulation-based methods to provide guidelines for what methods to choose. So that's a paper I tried to replicate with this paper here on confirmatory factor analysis with ordinal data. So you can I think they have. If you have like categorical data, you're doing a factor analysis, you can do like maximum likelihood or weighted least squares. And the conclusion, I believe, is that both are like working pretty well. And I think I was able to replicate most of the results. I mean, I have the code. I didn't put it into GitHub, but I mean, if anyone is interested in that, I'm happy to share that. If you want to just take a look on like kind of the code for doing like exactly a study that have been published, I am happy to share that. Yeah.
That's really interesting with the because with ordinal data, there's obviously there's a move at the moment in psychology to try and go more towards ordinal regression. And there's been a couple of papers by Paul Bruckner and Krushke, I think,
right,
yeah.
right.
So that'd be a sort of an excellent thing to be able to do maybe in a future summer school, would be how to simulate ordinal data as well as like continuous stuff. But that's really fascinating. When you said so those are replications. So is that it has the same distinction as reproducibility and replicability. So it's not like you just take someone else's code, try and run it, get the same numbers out. You actually start with the same question and try and construct it yourself from scratch. Is that how it works?
Yeah. So I think one of the motivations is like people in the past, they don't really share code for simulations. So you have to like. So I guess the first step is really trying to reproduce their results in terms of like if you use exactly the same conditions and use the to the best of what you can to like follow the same procedure, they simulate the data, whether you get the similar results. And actually, it's not an easy task because there are like challenges, and that kind of highlights some of the problems in some of the studies because they. Like this paper, I mean, it's a great paper, but at the same time, like there are things that I wouldn't be sure when I actually need to simulate the data to replicate results. I wouldn't be so sure whether they might not report how they simulate the ordinal data, or they report how they simulate the data, but they didn't report some of the key parameters. Because with simulation, you really need to know, you really need to set all the parameters in your population. But if they did not report one, you have to, like in my case, I have to try to guess what they meant in a particular case, and that might lead to issues of not something not reproducible. So that's kind of, I can see that's the benefit of like doing more of these in terms of just making things more transparent, making people more aware of what are the things they need to report when they are doing a simulation. And I think that's, I mean, that applies for a study, but I think that applies for like, if you're just using simulation to illustrate some other things in an applied paper, I think it's still good to be clear of all the parameters you use to exactly the procedure, and the best would be to provide a code for people to just reproduce it. Yeah.
Great, thank you. I'm gonna pass that over to the floor. Has anyone got any questions they would like to ask about Monte Carlo simulation in general, simulation papers, anything like that? Yes, we got a hand up. Who's hand? Oh, Jeff again.
Jeff?
Great, thank you.
Yeah, well, if there's nobody else, I might as well.
Yeah.
You know, one thing that I've noticed, at least in the simulation papers I've read, and maybe this is just a weird coincidence, but maybe you can tell me, is that it seems like when people do the simulations, when they actually want to then do comparisons of the results, it seems like it's very common to use like ANOVA and things like that. And I was just curious, like, why is that just sort of a convenience thing, or is there some reason why that tends to be used over yeah, I don't know, like regression-based methods, or is that just a coincidence that I've noticed that?
Yeah, that's a fabulous question. I actually have been thinking something similar, like recently over the past year. It's my theory. It's just my opinion on this, but I think it has to relate to like Monte Carlo study being an experiment itself, and the experimental tradition has a strong emphasis on ANOVA, on being the way of analyzing data. And I mean, ANOVA is, I think you're right, ANOVA is usually used for like running, I mean, summarizing simulation results. Even though a lot of the times people might not actually conduct a significance test, they might be just reporting an effect size or plotting the data. I think it is a good way to think about, or to structure how we want to summarize the results of a Monte Carlo simulation study. But at the same time, I agree that there should be better ways, and I actually thought about writing something about that. But I can imagine, like, because you can have, if you think conceptualize your conditions you chose as a random effect instead of a fixed effect, you can actually do a mixed model instead of an ANOVA to summarize results. And I can argue that it might be better, where you can pool the errors together, and if that might help you reduce the number of replications. Relating to your first question, that might actually be a practical way to go for it. It might reduce your mean squared error. And I think that might be the same for, like, if you're doing power analysis. If you're doing power analysis, usually people want to like find out the sample size. You try like 100, you see your power is 70%. You try 200, your power is like 80%. And then usually people just try to get to the point where you have 80% power, but you can actually like kind of fit a regression line to all the trials you've done, and that might actually give you more precision in estimating the power. So that's a thought I had before. I actually tried out something, and it seemed to actually reduce the number of like replication you really need to get the same precision of estimating power at 80%. So that's yeah. So I mean, to answer the question, I think I would highly support like opening it up to allow like other kind of methods to be used to analyze simulation results. But it, to my knowledge, it hasn't been discussed a lot in the field. So I guess it takes time to, or takes someone to say something to change that, or to open a discussion on that, like what we are doing here.
Cool, thank you.
Mm-hmm.
Thanks for the question. Do we have any other questions at all? There's a few people who've just popped in. Just going to say that the videos for this session are all available on YouTube. We've linked them both on Twitter and on the YouTube link on YouTube. And the goal of this session is just to have people ask questions and things like that. Oh, I'm quiet. I'm quiet now. Okay, sorry. See if I can fix that. That better? Is that better?
Yes.
Yeah, brilliant. Thank you. Cheers.
Yeah.
Cool. I don't know what happened there. Yeah, it's just opportunities to ask Mark questions about the videos or about Monte Carlo simulations in more generally. Does anyone else have any questions at all?
Yeah, feel free to chime in if you have any questions. I mean, if you have issue accessing the materials, or like finding out the R Markdown files or whatever, I'm happy to like do that. Or even if like it's simulating other types of data that we didn't discuss, I'm happy to like to explore if that's something of interest to anyone, any of the audience here. Yeah.
I didn't finish the I didn't. Oh, I've got a hand up. Brilliant. Oh, great, excellent. Go for
it.
I'm sorry. This might be something that you actually discussed in the videos, so I'm going to watch those this weekend, but I haven't had a chance yet. But yeah, I guess I'm just thinking about, you know, the process of simulating data for you know, this type of method. You know, I think, you know, you think about the, you know, what is the data generating process for your real data that you're sort of theorizing or imagining, and then you are going to add some kind of, you know, perturbations to that. And I imagine mostly sort of like Gaussian errors or something. And so I guess I'm just wondering, like, can you talk a little bit about, you know, what's the process of really trying to go through that process of, you know, imagining what's the right way to simulate this data, how much error to introduce, and again, apologies if you discussed this in the class.
I think that's a great question. I don't think I discussed that in the videos. Yeah, it's this kind of it's one thing with like mathematicians or statisticians or methodologists is we can kind of have this imaginary world where we can consider like the data might look like this, the data might look like this, and then we can demonstrate what would happen if I analyze the data using that method. And actually that's something that the review process will try to get to when Ollie asked about the review process. I mean, reviewers will wonder whether your simulating process is similar to what the actual data looks like. And if we are doing in psychology, we want to know whether the data looks like the data you will see in a real world. So I think for me, usually it's a good place to start is just to look at like other people's data and then trying to find out what the characteristics would be look like, and like what other if say that I'm simulating data from a normal distribution or Gaussian distribution, should I use like the mean of 30 or 50 or whatever if I wanted it to look like some of the data that in a particular field, like say maybe cognitive functioning, for example. What are the average cognitive scores? It helps to kind of concretize it in like embedded in like a real life example. But at the same time, that's where the statistical theory would come into place. Is on like if you're simulating data as a normal distribution, then really the mean doesn't really matter, like how large or how small it is, because you can always standardize your score and your results would be the same. So that kind of knowledge would help, like something would generalize if you simulating it to have a larger variance or smaller variance. If you just have one variable, it doesn't really matter. But if you have, say you have you're doing regression and you change the error variance of the regression of the outcome, then you change the R square, and that's when it matters, because we know it matters with power. So that's on kind of the parameters. And also you asked about like distributions. That's kind of the thing that I don't think methodologists agrees on. Like we agree on, like usually we start with the normal distribution, because that's usually what the standard models are about. And if the standard models make the assumption about normal distribution, we usually do it first to see if the data behaves as the models say it would, and what it would be like. But then when it goes from normality to non-normality, it becomes a much trickier question. So ordinal data, for example, do we like, and in ordinal data, there's like theories about you actually have an underlying continuum, that underlying variable is normal, but you are just cutting the normal distribution into multiple categories into like anything in the normal distribution. Maybe the normal distribution is 0 to 10, something like that, but anything below 2 becomes a 1, anything from 2 to 4 becomes a 2, and something like that. That's kind of again, theory comes into place, but also like kind of the type of data you want. So you need to find a distribution that match that. Maybe if you're studying response time, you might be looking at things like a log normal distribution that is like strictly positive. So it's kind of opening it up to multiple options of distributions, and some of the models that people use would kind of give some information on, like people doing X-Gaussian, then you simulate data with an X-Gaussian, or maybe with some other types of data.
Great, thank you.
Do we have any other questions from people in the room? You can use chat. You don't have to talk on the you don't have to talk on the microphone. I'll read out any questions that come up on chat. Don't seem to be at the moment. Oh, hang on, no questions from me. Oh, yeah. Anastasia says no questions. Thank you for the interesting materials. Yeah, I think I can echo that as well. They're excellent.
Yeah, thank you, Anastasia. And so I know it's kind of like a rush sometimes with because people might come and expect like I'm going to talk about something, but it's kind of a different format. But happy to take questions afterwards if you have anything watching the videos. I may just put my emails on the chat. It's on the videos as well. But if anyone has questions, just feel free to chat with me, and really enjoy like chatting with people about simulations.
Great. What are your grad students working on at the moment?
What's that?
What are your grad students working on at the moment?
Oh, my grad students.
Yeah. This is Winnie and Ichi who also did the videos. Just saying up to everyone else.
Yeah. They are both like great students of mine, and so they're both in their second years. going from the second to the third years in their PhD. So they are in the quantitative psychology program. So it's kind of it's the program that usually do methodology research. So Winnie is doing a study on power analysis. Actually, it's a study about how to incorporate uncertainty into power analysis. That's actually a paper by Muxing and Balkenhol, but also like actually there are a lot of papers in the past. But it talks about the question of if we're doing a power analysis, we want to find the required sample size to get our to be able to get 80% of power to detect an effect which we assume would have a size of something. And sometimes the power analysis is done based on a pilot study, like maybe the pilot study suggests the intervention effect has a coherence D of 0.5, let's say. And so we use that 0.5 for our simulation and or for, it's not simulation, but like for you plug it in and you use G power, for example, and you get the power. But the problem is that 0.5 value is not the true effect size. Like if we know the true effect size, then it's not necessary to do a power analysis. So so she was like have this idea about how to incorporate that uncertainty into the power analysis process, and you so basically it's assigning a prior distribution on the effect size, and then it incorporates all the uncertainty into it. So now you get like every different values of the effect size, you get a different required sample size. So you can have like a full posterior distribution of your sample size, but you can kind of take the posterior mean of that would end up being more being larger than usually the original sample size. But it's like it gives you a better representation of all the uncertainty, and it saves you from like having to have too low a sample size that you need. Because might be your effect size doesn't turn out to be 0.5, it's actually 0.25, for example.
Yeah, that's amazing.
And she's doing it, and she's doing it for multi-level data, like cluster randomized trials, where you have you may have there's another parameter which is like ICC, the intra-class correlation, talks about the proportion of between variances as opposed to the total variances. That usually is a parameter that you need to guess. But if that parameter is not certain, then you end up not getting the right sample size. So she's doing that. So it's incorporating both uncertainty in effect size and sample size.
Awesome.
I mean, effect size and intra-class correlation. Ichi is doing some work about measurement invariances. So it's more in the structural equation model framework, with like looking at tests, whether there are biases across cultural groups, across demographics. Examples like we know, like a depression test, there's a question about whether you have been having crying spell is known to like be more indicative of depression, at least in the United States, more indicative of depression for females than for males. But if we kind of use the same cutoff, we end up like the scores are no longer comparable. We couldn't take a 5 for a female score and a 5 for a male score. They are like not necessarily comparable. They don't indicate the same depression level. So she's developing some way to quantify how much bias there is in like this kind of survey questionnaire screening tools in psychology.
Amazing.
Yeah.
Great stuff. Yeah, that's very fascinating. Fascinating stuff. Cool. Do you think we live in a simulation study?
I don't know. That seems a philosophical question.
If we've been programmed not to think of it. So.
Yeah. We might be a robot just I don't know. It's maybe ask the numbers. Maybe the data in the simulation being simulated. Do they know whether they're being simulated or not? That's the question.
It is. Okay.
Oh, Shadi.
Oh, nice.
Yeah, I haven't met Shadi, but I'm really excited to meet her because we have been on COVID leave for the past year, but we're getting back in person, so I would definitely say hi to her. Thanks, Jeff.
Great. Thank you. Any last minute questions before we close up, Suzanne? No? Okay, great. As I say, the videos from the asynchronous session are all available on YouTube, so filter through those. And Mark's offered to answer any emails after the session if there's anything that you're confused about or whatever. But otherwise, I think, yeah, thank you so much for your time. Mark's been brilliant talking to you and had some interesting questions and answers here. Anything else you'd like to say before we close up?
Yeah, I just wanted to say say thank you to Jenny and Ollie for organizing the great section.
Oh, no, thanks.
I mean, yeah, it's just I wish we had something like that in the United States. We probably have something I'm not aware of, but yeah. But I think this is great list of resources. So
great, thanks, Jeff.
Really, thank you.
It'd be nothing without the contributors.
Really nice. Yeah, really nice to meet all the audiences, and I hope to just keep in touch and hear more about how you use simulations.
Will do. Thank you so much. Cheers, Mark. Goodbye now.
Yeah. All right. Bye.
Bye.